Now that we already know how to make simple plots, and we know, for instance, how to put many curves or data points in one simple figure, we can move on to making multiple subplots within one figure. So now the difference is that if normally we had figure window, it had that plotting area, and then up to now we looked at how to combine different things in one graph. But sometimes you still want one figure window, but broken down into smaller areas where you try to graph something else. And these are called subplots in Matlab. And you could actually have any kind of arrangement of subplots you like. And the main thing that you have to mind is how many there would be, how they are combined, and how you can kind of break them down into kind of matrix layout. So for instance, a figure like this would mean that there are 2 rows of plots and 2 columns of plots. If you assume that they are kind of equally sized this. So let's see how it's done. So the command in Matlab that helps you do the subplots is called exactly subplot. And it takes in 3 arguments. The first 2 define what will be that kind of matrix of subplots that you actually want to make. And the last one defines which one you are plotting at this very moment. So this n and m is understood the same as in any other matrix, that m is actually number of rows and n is number of columns. And then how the I goes, well, if you have, let's make it like this, that we will have actually 2 by 3 layout. So we have 2 rows of plots or subplots, 3 columns. So that means that we would have subplot 2 and 3 in here. And then that last one, how it goes, basically you go through them in this order. So it always visits rows. So how Matlab understands which subplot is which is in this way. 1, 2, 3, 4, 5, 6. So if I have here, for instance, subplot 2, 3, 5, it means that under it, whatever I put, defines the content of this 5th subplot. All right, so that's all about the practice, the theory. And how about we look how it's done in practice. So this one example shows we have 4 different functions that we want to plot in 4 different subplots, and we would like to arrange them like 2 by 2. All of them should be done for this interval 0 to pi within one figure. So t comes from this interval. Okay, so how it's done in the code? Well, t is universal for all 4 subplots, so we can define it before everything else is done. So I create a vector starting from 0, ending at 2 pi. I'm using now the Matlab's value of pi, and I give it some small step to produce the data points. This could be anything. You can also put something like 0.01. That's fine. And then we start to go through the subplot. So the first one is just supposed to plot cosine. It's actually supposed to plot cosine t against sine t. Now, in plotting language, when you plot something against something, so that something you plot is here on y-axis, and against means that that against thing is on the x-axis. So this would be the arrangement for our plot in here. Cosine plotted against sine. Okay, and we want to place it in the first subplot. So this part now, up to here, defines what will be in that very first small window of our figure. And that's why there is 1 here. So I say I want 2 rows 2 columns, and the first subplot being created in here. So let's go into Matlab and let's save our file. Okay, let's do the basics. Clear all, also close all in case I have anything open. And we start. So we said that we were plotting subplot in the arrangement of 2 rows, 2 columns, and now the first one. And of course I needed my t vector to be defined before, so it was from 0 with some small step up to 2 times pi. And then in the first one we were supposed to plot cosine t versus sine t, so again versus, or what we plot versus goes to x-axis, and the one we want up there is cosine t. We can do some labeling or just title. You can do the labeling. We do it the same way. So whatever appears now in after this plot belongs to that subplot. As long as I don't point that I'm pointing another subplot, all this labeling will actually be placed for that particular subplot. So I'll say cosine t versus sine of t. Okay. And now let's see what happens if I just leave it like that. So let's not put any other subplots. So now when I run, change the folder, and so what happens is that Matlab creates that first subplot for me. So you see, it is ready to make the whole figure with more contents, but since I only gave content for the first subplot, it only made that one. It didn't even kind of prepare empty slots for the next ones. Now if I say here subplot 2, 2, and 2, so what happens is that now I have pointed that there will be a second subplot, and so I wanted to kind of prepare the area for it. If instead of 2 I've put 4 in here, we would see empty area in that second subplot spot, empty in the third one, but a prepared thing for the fourth one. So you see how this numbering goes. So as long as subplot command has not appeared for a specific area of a subplot, then it will not be filled in at all. Okay, so let's do the other two. And also what I said is that if you have title, or the same for label commands and legend, they are always valid within that specific subplot. So since I placed it right after my plot in here in the first subplot, then that title really appears on top of that first subplot. All right, what were the next one? So second subplot is supposed to have the sum of sine and cosine, and yeah, that's it. So let's code that. We can even do it directly. So we plot t versus, our result versus t. So t comes on x-axis, and then here we have sine of t plus cosine of t. And of course I could again make the title here as well. And run. So you see there is a piece of our function plotted in here. One comment also about this first case, those of you who remember a little bit from math, this is actually a circle, sine and cosine plotted like that, and you actually see that it really is like the x-axis is scaled from -1 to 1, and y-axis from -1 to 1, so it actually is a circle, but if you remember, Matlab's figure is by default in this kind of rectangular shape, so now since the numbers here are nice, it's 1, 1, so Matlab wants to fill that entire circle in the plot, and it kind of makes it look like an ellipse. So if you want that circle to actually look like a circle, there are two ways in here. One is to make your axis equal. So if you add here the command equal, you see now it actually is a circle. If you try to measure, this is exactly same as that, because then it puts the same scale on both, and it ignores the fact that how the axis ends is not kind of a nice looking number in there. The other one was to make axis square, so what would happen is that Matlab would actually kind of cut off these two sides completely, and we would have a square figure area in here. Okay, and we are left with the other two subplots. 2, 2, 3 was, let's see, what was the formula? So the third one is in here, and we are now having multiplication of sine and cosine. Now remember that since t is a vector, sine t is a vector and cosine t is a vector, they are equally long and same or oriented in the same way. So that also means that the multiplication of them has to be element-wise, so that's the one with the dot. So we have plot, again we plot versus t, and then it's sine t dot times cosine t. And let's put the title again. Alright, and let's put the last one, subplot 2, 2, 4. So that was supposed to be in here. We have z as a difference between sine squared and cosine squared. So again t, and then in here we have sine t squared. So once again, sine t is a vector, so square has to happen element-wise. And remember that in Matlab you cannot do it in here, because then Matlab thinks that sine itself is an object that we want to square, but it's not the sine. Sine is the name of function, so first you have to say sine of what, and when this is calculated by Matlab, then you do the power. And then minus cosine t squared. And the title. All right. What happened in here? Oh yeah, I had this. This was supposed to be times. Okay, and actually, yeah, I accidentally made actually sine t power cosine, so that's why there is this funny looking graph in here that was actually supposed to be a multiplication. Yeah, so now we have all four subplots. Doing the subplots one by one is quite okay when you don't have too many of those, but sometimes you may have many variables that you want to plot. You want to plot without having to copy paste a piece of code too many times. So that can be done in a loop, and that also means that this index which subplot we are currently working with can also be kind of automated. So if we look at the next example, for instance, in here, if I want to, I generate uh, 10 rows of vectors of random numbers. So I'm actually creating a matrix which has 10 rows and 1000 columns filled with random numbers, and I would like to plot every row as one subplot. So now what happens is that I can actually make it in a loop where here I have defined how many rows and columns I want in my subplot. This is your individual thing. If I know I have 10 of those, so 2 by 5, 5 by 2 is something that fills up the figure nicely. And then here we have that k now, which will be changed using a for loop. And we just say that every time for each next kth subplot, we want to plot kth row of our matrix. So once again, let's see how that goes. We have our x around 10 and 1000. It can also be maybe just for showing or arrange them differently. Let's comment that part. So now when I run, you see x actually becomes a matrix which has 10 columns. Now it can't fit all of them in this narrow window. That's why it shows 1 through 9, and then after it has displayed all 1000 rows, it shows here that column 10 as well. So it has 10 columns with 1000 values in every, and 1000 rows. You can see by checking it here also, so 1000 by 10. And what we want to do is we want to plot those individual columns. So I will make a loop. I'll have some index changing from 1 to, here I could put just 10. I could also put size x2, so I tell Matlab to check in case I change this number of columns here. I tell Matlab to check it for me, how many subplots we actually need. And I want to arrange them, let's say 5 by 2, so 5 rows and 2 columns of subplots. And then every time the loop makes one step, it should look at that particular ith subplot. And within that subplot, it would plot that ith column of my data. So x, sorry, I. In here, we don't have anything to plot them versus what, so that's why it's okay to leave the x-axis argument out. If we had some information what to put there, that would be okay. And I also put axis tight. So now, when I run this, Matlab will actually plot all those. So now it plots them as lines. And you see, I told it to make 5 rows, 2 columns, and in each of them there is a different vector of random numbers. Okay, and now another thing is that now I have actually told manually that I want to have this layout of subplots 5 by 2 because I knew I have 10 columns. But now if there is more in here, that means that it wouldn't work if there is, for instance, 12, because Matlab will not be able to access 12 subplots in a figure which only has space for 10. So what you can do is actually automate also these ones. And an example is given, for instance, in here. So now how this works, that it is looking how many variables that you want to plot we have, so that's n. And then if you want, for instance, arrangement that you have many rows of subplots, but just 2 columns, so then it's easy because you know the number of columns is 2, so the number of rows is half of that. So that's why in here we have n divided by 2, so we know that this many rows we would need. Why I have this ceiling here, so that the rounding upwards, well, simply to prevent the case if my n is, for instance, if my n is odd. So if n is 7, if I try to divide it by 2, the answer is 3.5. So in this case, Matlab would be confused to have a matrix of subplots 3.5 by 2. That's not possible. That's why we round upwards to make sure that if it is, then it will turn it to 4, and it would make a layout 1, 2, 3, 4, 5, 6, 7. So it would plot those 7, and then the 8th one would be empty just because it wouldn't have that k equal 8 anymore in plotting. So this is just an example how to make that automation, and you can play with this formula in here based on the layout you would wish to see. So just to demonstrate that one, once again, let's make y a bit bigger. Maybe 20 or 15. Let's take some odd number so that you see what I was trying to explain. And then I'll take that piece of code since it's mostly okay for us. Now we have size of y2 and y here. But as I said, I will still kind of prefix the 2 columns, but here I'll say ceiling of once again this size. We could even define it here as n to reduce on typing. So this becomes n, and in here ceiling n divided by 2. So we know n is 15, n divided by 2 will mean 7.5, but ceiling rounds it up to 8. So the layout of subplots will be 8 by 2, with the last one now being empty just because there is 15 variables. And again, we could have had some automated title added if we had, for instance, a cell array containing names of variables. That one could have been used to automatically also label the titles. But that I will show in a separate example.